This example comes out of section 1.4, using limits to find tangents. In this question, we're asked a similar type of one as the example before that said find the tangent line, or the equation of the tangent line to the hyperbola x times y equals 1 when x equals 3. I took this one from your book intentionally just to show you that when you have x, y equals 1, you really normally would write that as y equals 1 over x. So there's the function you're talking about. You even hopefully have some idea what that looks like. And they're talking about when x equals 3, we're looking for the tangent line at that one particular spot there. So I'll just use one of the equations here. Let's use the limit as h goes to 0 of f of a plus h minus f of a over h. So the limit as h approaches 0, this is to find the slope of the tangent line, is f of 3 plus h minus f of 3 over h. So the limit as h approaches 0 of 1 over 3 plus h minus 1 over 3 divided by h. So that's somewhat inconvenient in that there's a fraction minus a fraction divided by another denominator, so you've got fractions within fractions. But if you recognize the fact that a common denominator here is going to be necessary to go about the next step, and the best thing or the most efficient thing to do with that common denominator is multiply the top and the bottom by that common denominator. Why that proves to be such a valuable step is, let's take a look at what happens next. 3 times 3 plus h times 1 over 3 plus h just ends up giving us 3 minus. Now, a third times 3 plus h is 3 plus h. And the bottom, I won't even multiply it out. I have h times 3 plus h. But at least I don't have a situation where I have fractions over top of fractions. So now I do have the limit as h goes to 0 of, notice the numerator here is negative h. 3 minus 3 is 0, and it is minus h, because the brackets there, I was careful with my brackets, over 3h times 3 plus h. The good thing about not bothering to multiply out the denominator is you realize, oh, there's an h on the bottom and an h on the top. They can cancel. The limit as h approaches 0 of negative 1 over 3 times 3 plus h is just going to be negative 1 over 3 times 3, which is 9. So the slope of my tangent line is negative 1/9. So if that's all they asked me, I'd stop there. But they did ask me for the equation of it. So y equals negative 1/9 x plus b. We have a point that this thing passes through, which was 3 comma 1/3. So 1/3 equals negative 1 over 9 times 3 plus b. 1/3 equals negative 1/3 plus b. So b equals 2/3. So one way to write this equation would be to say y equals negative 1/9 x plus 2/3, and that would be acceptable for most situations. If you check answers in your book, you won't get that. They'll get rid of denominators first by saying multiply everything by 9 here, so negative x plus 6, and then put things in order to say x plus 9y minus 6 equals 0. For most of my test questions, the slope-intercept form is perfectly fine. If you're checking answers in the back of the book, you'll see something that looks like that. But there's another example of using a limit to find a tangent.